Hello. I'm working on a pretty crazy project here, so I figured I'd just go live. Apologies in advance to anyone who's not here, but that's just too bad if you're not making it to the show. So, we got two people. Welcome to the chat. I'm here to just talk about what I'm working on, and if you have any questions about current events or anything cool going on in 3D printing, then let me know. Nuno knows what a tube is. Yes, so this is a new hot end. I should leave a link to it, but you should recreate your bamboo ANET on stream. No, I returned my Bambu Lab. I'm done with bamboo. You should know that. No, this is PETG. And just to give you a sense of scale, I mean, it's hard to tell what's going on here with... Oh, geez. Dropping my laptop. It's hard to tell what's going on here, but here's a SD card. I'll just plop it in the middle. So, I don't know. It's pretty large stuff. Yeah, so this is the tube hot end. It is, well, it's just kind of crazy. So, I mean, it's supposed to be a high performance hot end that can go up to very high temperatures. I actually got one of these while I was checking out Luke's lab. So Luke's lab, shout out to Luke's lab. It's just a really high performance hot end. The application is for industrial machines or really enthusiastic people such as myself. And you can see it's laying down some fat layers here. I hope it's cooling everything off fast enough. I think it's cooling everything off fast enough. We'll just let it go. But you can see this pattern it's making. It's quite interesting. And the PETG I'm using is optically clear. So it looks quite cool. Oh yeah, the Benchy. Yeah, so I got tired of having all these Benchies around and not having a use for them. So I figured it would work as a CR touch holder here. So it's actually holding on to the bed leveling probe. And that's what the Benchy does. And all this extra wiring is because I was originally planning on running all the wires down into the main board, but instead I decided to stick with the Ender 3 S1's main board, which uses the 24-pin cable, and I have that paired up with one of my breakout boards. So this is called the Modder board. This is something that I designed and produced and sell. It's the product of basically me trying to make the Ender 3 series moddable again. So I've got a couple test prints I want to run on this thing, and I want to show you guys. So here it is. I'm not sure how to get this tuned to have it run real nice. You can see the perimeter layer. Look how burnt that stuff is. This was, I was doing some troubleshooting and doing some work to get this going, but it's finally going now, so we're able to show it off. No part cooling fan yet. I mean, part cooling is important for a lot of materials, but for PETG, it's not all that important. Zblurth, you see the tube. Yeah, so I actually have, this is one of the prototype tubes. It's not like the fully full release version, but it still works good. One thing you got to admire is a company, or, you know, in this case, Luke's lab, who is producing and selling these. He actually put a lot of time and effort into making sure that the thing works before shipping it out, so even the prototypes work quite well. But apparently the newer ones should work even better. This is not glass, this is just clear PETG. And it's being fed at quite a high rate of feed. You can see I'm pinching onto it, and it's being pulled into the hot end quite fast. This is one of the things I like about the Ender 3 S1, and actually all the new Ender 3s, is how beefy these extruders are. Like, Creality's providing you an incredibly powerful extruder, total overkill for the type of machines they're shipping them on. And you can pair it up with a really high performance hot end like this and get some insane flow rates out of this. So this is only, well, let's see. 235%. The profile is set up to print at 25 millimeters per second cubed. So this is only about having to do math on stream. It's about 58 cubic millimeters per second of PETG, and I'm printing this at 270C. I'm doing over temperature just to make sure at these high flow rates it'll work well. But yeah, so let me touch this over here. Yeah, that's the heat break. It's a little toasty. I don't have the best heat sinking solution on here. It's basically just bolted to this with no clear thermal path, but it's sipping enough, enough of the heat out of there to keep on working. Just using the stock fan that's on the Ender 3S1. Yeah. So the other thing that I've got here is this this plate. This is something that I'm going to be excited to bring to market pretty soon. This is going to be on my store. I'll probably list it tonight or tomorrow or something. But this is what I'm calling the Ender 3 unification plate. It will allow you to put all sorts of mods on every type of Ender 3, regardless of like what model you have. It's compatible with all the Ender 3s. And yeah, so yeah, this is a thick plate. This is like a special plate that's super flat and strong and like really well suited for this application. And the cool thing is it acts like a giant heat sink too. So it's sucking heat out of the power supply and out of the main board and helping keep everything cool. Yeah, I'll zoom out a little bit so you can take a look at it. But yeah, it's got all these holes all over the place to make sure that it can, be compatible with everything I'd want to put on it. And it's also going to be the base platform that I produce my own 3D printer off of. So, this will be compatible with all the Ender 3s, but also it'll be compatible with my future crazy stuff that I'm going to build. So yeah, here's the tube hot end. For those of you who haven't seen it, I'm spitting out 68 cubic millimeters per second of PETG, and it's making this really interesting beaded glass kind of look, a glass bead kind of appearance. I could get a fan on here to kind of, go in all-wheel drive. Yeah, I'm thinking, I actually put a large clearance cutout over here so I could fit up to 6 stepper motors in the front and back and be like moving the axis super fast. But honestly, I don't think that's really useful for that many people. And the nice thing about this aluminum plate is it's soft enough that you can cut it yourself if you want to add extra features. Like a lot of these tapped holes I just put in there as I was doing my modification process. So yeah, 68 cubic millimeters per second right now. Let's see if we can turn it up a little bit faster. I actually haven't seen what the limits of this thing are. So let's increase the speed. Of course, I'm running this off of a Sonic pad because why not? So 310% speed, that should be the equivalent of 75 plus cubic millimeters per second of PETG. And you can see the part cooling is really struggling to keep up with this thing. I'm just going to let it go and see what happens. Anyone else curious to see what happens if I just let it go? I wonder if I'm getting any under extrusion issues. It seems like the filament is being fed properly. Okay, well that's that. Layer adhesion test. These layers are going to be super well adhered to. Oh man, there's the this plastic that's sitting over temperature. Let's cool this thing off a little bit. I'll tell it to preheat, and that's actually going to cool it down because the preheat temperatures are lower than the actual printing temperatures I've been using. But yeah, here's the PETG part. Looks interesting. The cool thing about this is if you've like studied welding and welding techniques and what a proper weld should look like, they talk about this idea of like a stack of beads or a stack of dimes being the ideal kind of appearance for a weld. And this has that kind of appearance. I mean, look at this single layer of extrusion. Let me get some regular extrusion. Put it next to it just so you can see what the deal is. Here's a regular piece of filament next to the lane, that one line of extrusion that I laid down there. I mean, just doing a one-lined wall print, you get some pretty good stuff off of this. So what does the future of 3D printing hold? It's got to be stuff like this, you know, cool projects. Let me cool this off and get it to detach. If I yank this off, I'll probably damage the PEI sheet just because of how well that's probably going to stick. Yeah, I'm going to let it cool off. What else should I print on this thing? This is the first time firing it up. I literally just finished putting it together and hit the go button. Right here I've got the Slice Engineering 2.4 millimeter nozzle, the tube hot end, which is sold by Luke's Lab, stock Creality extruder, got my breakout board on the back, the Modder board, which is specifically designed for Ender 3S1s. 3D printing moon dust, I have no idea what that's about. Oh yeah, like if you wanted to print a moon base, that could be cool. Oh yeah, also, this is the first time I've managed to get the screen horizontal. Normally I was always filming like this, and everyone was like, hey, come on, fix it. Alright, I fixed it. Now you're all horizontal. Are you happy now? Yeah, so I learned a lot about that, you know, just because I was interested in it. I like to study that kind of thing. But yeah, that's a big application of 3D printing, is being able to 3D print bases on other planets. You could send down a 3D printing robot that could build all these things. Anyways, this is like the, what do you call this thing that goes around the edge? Is this like the skirt? This is just the skirt. I don't know. Let me compare it to some other things. It is compared to a Benchy. It's a very large skirt. Okay. Oh, and this pops right off. Here's our PETG print. So this should be incredibly strong. I'll let it cool down a little bit so that it gets the full strength. But this is like toasty. This looks like an old school Fresnel lens. If you ever looked at like an old headlight on a car, like a classic car or something, or a motorcycle, they have those concentric rings. You might be able to 3D print a Fresnel lens. Yeah, slightly see-through. Sorry if I'm not hitting all the questions. I'm just doing this on my phone, so I might be missing a thing here or there. But yeah, what do you guys want to print next? I can load up anything on this thing. Something in vase mode would be ideal. I might try out some high-flow, high-speed PLA. See how fast we can get printing with that. Katana blade? What do you mean katana blade? That doesn't make any sense. Alright. And of course I'm using the Sonic Pad, the ultimate clipper experience. Katana blade in vase mode. I don't know. How am I going to make a katana blade in vase mode? That doesn't make any sense. Headphone holder. Oh yeah, thank you. I cleaned up the other day, so it's looking pretty good here. I mean, thank you for recognizing that I did a good job cleaning up. Panda, perfect gift. Oh, what do you guys think of the A1 hotbed fiasco that's going on? I'm gonna switch it around here. Wait, let me see. I can reverse the screen so I can read stuff here. All right. It's just a simple box. I can do that. Collapsible katana. Here's the thing about the collapsible katana, Matt, is I'm probably gonna have issues with that, just because. Glad I have the A1 Mini and not the A1. Hi, Luke. Oh, yeah, we're showing off the tube today, so it's up there printing. If you jump back a little bit, you'll see it printing. I literally just plugged it in and started printing with it, and the thing works great, so good job with that. Everybody check out, if you're interested in this hot end, it's called the Tube. like CHUBE, and Luke's lab is selling it. It's a pretty good thing. It's been working really well so far. Hopefully we get some more use out of it. Chube. The Chube. CHUBE. Yeah, it's, yeah. All right, so we're gonna slice another model to slice on here. Oh, someone said, let me read that comment. The chat is going by too fast here. Live chat. Okay, here we go. I can see now. Did you take your K1C extruder to see if the gears are all metal? Okay, here's the thing about all metal extruder gears. It doesn't matter. Okay, I know this might be a surprise to a lot of you, but metal isn't always better than plastic. 9 times out of 10 it is, but sometimes metal is not really any better. So you don't need all metal extruder gears unless you're printing in an enclosure above 80 or 100 degrees Celsius. For most people, just the nylon gears are fine. I do think it's silly that Creality said they have an all metal extruder. Their definition of all metal is kind of weird. I guess like the skeleton of the extruder is all metal. But at the end of the day, it's kind of a non-issue. I don't think it really matters. Something on the topic of extruders, if you actually look at the Bambu Lab A1 and A1 Mini, yeah, I know I'm using this as a tripod here. There we go. On the Bambu Lab A1 and A1 Mini, they say it has a dual gear extruder, but really it only has a single drive gear extruder. So if you want to be upset with someone, go check out the Bambu Lab. Yeah, all metal hot end, that might be what they meant. Hey Lightspeed, welcome to the stream. Okay, so I need to slice a model to check some stuff out, get some more prints on this thing. We'll see how it works. This is actually, sorry this view of me isn't super interesting, but I promise we'll get to the interesting stuff. I think I'll just do one of these trash bins. That'll keep everything busy for a while. I'm not printing any more Benchies. I already have a Benchie on the printer, and that satisfies the Benchie requirement, I believe. So yeah, here's the trash can. I think that should work. This will have, according to my print settings, the walls will be 1/2 centimeter thick, so, you know, very thick extrusions. That's something I want to print out, so yeah, we'll do that. I'm going to get rid of the brim or the skirt because that's actually a significant waste of plastic to print out a skirt that's that big and wide. Oh, that frame? Don't worry about that. That's another printer I'm working on. You don't need to concern yourself with questions like that. All right, so here's I'm glad somebody noticed it, or maybe I'm more concerned than anything. All right, so I'm going to slice this up. It says that'll take 9 hours and 38 minutes, but in practice, I'm going to be able to speed that up quite a bit because basically I slice these things with a 25 millimeters cubed per second print speeds, and then I turn it up on the screen so that I can control how fast it's going. It's really important to be able to have that control on a prototype printer like this. So rectangular bucket, we'll slice this, and we'll send that over to our printer using the lovely Creality print interface. File list, upload. So, yeah, it's been a while since I've used the Sonic Pad. Sonic Pad's actually pretty cool. I don't know if you've ever set up Klipper from scratch, but being able to just press a button and have it work is pretty nice. All right, we'll give this a print. All right, oh no. Someone's saying the Bambu Hit Squad is coming. Oh no, that's too bad. I don't think they would do that. I haven't done anything wrong to them, right? I've never done anything to upset Bambu Lab. I helped sell him a lot of printers. If you knew how many printers I helped him sell, you'd be shocked. And they kicked me out of the program because they don't like it when I say mean things. The Bam Fam. Okay, so anyways, for those of you who just joined and haven't seen the printer that I've been working on, this is the this is it. So yeah, there it goes. Oh no, oh no. Okay, that was a little sketchy. The this solidified filament on the end was enough to bump into the bed because it's like a couple millimeters thick. All right, so that's something I might need to work on there. Fortunately, my universal benchy mount is flexible enough that it was able to absorb the flexing. Also, this hot end is built like a literal tank or cannon, and it's not gonna break. So I was doing some stupid stuff when I was setting this up, and it just kept ramming into the plate. But the way this thing is constructed, I don't know what the actual load limits are, but you can probably, I could probably stand on it with how strong it is. That'd be a great little sales demo, wouldn't it? Standing on the hot end. Yeah, okay, so Lightspeed and I are the only YouTubers that are persona non grata that Bambu Lab does not allow into their affiliate program because we're meanies, I guess. So, that's too bad. What am I printing now? So now I'm printing out another one of these large trash can models, except this is going to be, well, let me see the estimate. I need to see how much filament we're going to be using here. Gotta clear off my desk here. Let's go to the Prusa slicer. What? Somehow I exported this. Oh yeah, there we go. So I'm going to be printing out one of these. It's saying it's going to take 9 hours and 38 minutes. I don't think it'll take that long. Also, it says it's going to use over a spool of filament. So I might need to swap it out halfway through. Bamboo think Nathan always say base things. Nathan, have you ever been involved in cryptocurrency mining? Yes, I have. I have indeed. It was a mistake. It's not a profitable endeavor. And cryptocurrency was a big meme back, 5 to 8 years ago. You have 60 GPUs mining? Is that even profitable anymore? I thought it wasn't profitable anymore, so that's why I stopped. I did it for like a year back in the day. Just, with my gaming PC. Millennium Mini Mill? What is the Millennium Mini Mill? Very low power rates for Kick Gunner. Okay, I don't know what this thing's waiting on. Did I mess something up here? Let's see. It's printing rectangular bucket. It cooled down. Print? Is it time to print? Done printing file. Yeah, I'm not sure what's going on here. Let's retry this. Rectangular bucket vase mode print. Let's go. Oh, you know what? Maybe it kind of freaked out because of that little fiasco with the bed leveling earlier. Now it's fine. There you go. Okay, so yeah, now it's heating up. That was the issue with the nozzle wasn't cleaned off, and it basically rammed into the bed, and it wasn't happy. But we're all good now. I'm gonna set something up over here. Tube. What is this abomination? Well, part of it is the tube hot end. This is something that is for sale at Luke's lab. Oh, you think your ender is cooler? Yeah, right. I just printed this thing. Look at it. It's very strong. Solid plastic. Hey, Seifu. Thanks for watching the videos. What's the Benchy doing? That's my CR touch holder. So yeah, I've got a very strong little print here. I don't know what else I can do to demonstrate its strength. So we're getting started with a large trash can print. I'm gonna run out of filament halfway through, so I'm gonna need some help picking out another color for this thing. And here we go. We're extruding. There goes the plastic. So how fast should I make this thing go? Right now we're going 75 to 80 cubic millimeters per second. I don't know if we should push it up faster than that. You can see how fast this extruder gear is spinning. You can see how fast the filament is being loaded into the hot end. Very fast. I mean, do you think I could hit 1,000 cubic millimeters per second? Adriana Ashley, yes, cheese has already been grated. All right, we got both the Ashleys here. 30 cents per kilowatt hour mining isn't that affordable, yeah. I mean, if you're using a mining rig as a space heater, then that's just pure profit. I don't know, do you think we should do 100 cubic millimeters per second? We have the most knowledgeable person in the world about the tube hot end here in the chat. So I don't know if he thinks it can do 100 in PETG. But let's just try it. Why not? Let's get it up to 325. Hit plus one more time. All right, we should be about 87 cubic millimeters per second now. PETG. Speed it up a little more. Oh, okay. Okay, let's slow it down. I think that's the limit for this temperature, at least. Oh no, let's slow it down. Okay. All right, there are limits to any mad experimentation. You gotta, sometimes you gotta scale it back a little bit. I could increase the temperature. So let's go ahead and heat that up a little bit more. Plus, oops. Oh, man, this interface isn't the best. This is the Sonic Pad. Let's bump it up to 300 Celsius. I have a PT1000 heater in here. So, yeah, it's chooching. It's chooching away. But yeah, I have it at 300C. Well, I just told it to go up to 300C, so let's wait for it to heat up a little bit. And at 300C, I think I'll be able to get 100 cubic millimeters per second out of this. Right now, we're going at a mere 75 cubic millimeters per second of PETG. Maybe a little more than 75. So the base speed is 25 cubic millimeters per second. And when we increase the speed above that, you multiply the percentage by the base speed. So I'm not sure what that ends up being. You know what? I'm also working on this plate. And if anyone's interested in picking one up, I'm going to put a couple for sale on my website. And I'll ship them out to you if anyone wants to beta test for me. Although I want to be very clear, this is definitely a beta testing experience. I'm going to do my best to make this product work well, but you never know how that's going to work, you know? Let's see. Hold on, I gotta check the battery on my phone. Oh yeah, we're good. We're good here. So, I'm gonna go live with this product, this plate thing that I've been working on. So if you know if you've bought a motherboard before, you'll know the website. It's Nathan Builds Robots. Oh no, sorry, that's the wrong one. NathanSellsRobots.com. That's my shop. I'm gonna put a couple of these for sale. I only have a few of them because we're in beta test days right now. I just have enough to basically do my experiments with and film some content with it and test it out. But yeah, the idea is to have like a really stable base platform that can be interchanged with a bunch of different Ender 3 models. So I could put, right now I just have all the Ender 3 S1 stuff on here, but I could do an Ender 3 S1 on the top and an Ender 3 V2 on the bottom, or, any combination of Ender 3 parts. And I'm also going to be using this as a platform for my own printer products and my own kits. So that's going to be really interesting and fun. I've been learning about a lot of this stuff. But yeah, just a really solid platform to build your 3D printer off of. That's the idea here. Anyways, let's go ahead and list it for sale. So if you head over to my website, you can take part in this crazy beta testing that I've got going on. I don't know if anyone's actually interested in being my guinea pig, but if you want to, that'd be great. And yeah. Okay, so we got a couple more people in the chat here. So this is the Tube hot end. Luke's Lab sells this. You can hit up his website, Luke's Lab. Luke's, I don't know how to spell it. Is it Luke's Laboratory? Luke's Lab. I just Google Luke's Lab and it comes up. So lukeslabonline.com. I'll show you his website. So this is it. This is the Tube hot end. I guess it's available for pre-order, but that's what I'm printing with right now. I've got a 70-watt heater in there and a PT1000 heat temperature sensor. And it's just printing away PETG right now. Yeah, so this thing, I mean, you can install it on any Ender product, but definitely don't get it if you're wanting something that works. It's like this crazy thing I've been working on, so could be fun. Been getting all these plates machined out. So yeah, here we go. We're just shooting out the plastic. I'm not sure if I can turn the temperature up even higher. Oh yeah, I can increase the temperature even beyond 300 C. So let's go ahead and do that. I think 310's the max. Yeah, that's the max for now that I can assign to this printer, because I just threw the stock firmware on here. I didn't modify the printer config file to allow higher temperatures. So this is what we're dealing with. A mere 310C. Yeah, I mean, so the thing about hot end heaters is you don't actually need that much heat to melt it. The hard part is transferring the heat into the plastic, because metal is very conductive. We're used to being able to dump 5, 10, 100 watts into a piece of metal and dissipate that heat. But when you're trying to dump metal heat into plastic, it's a lot more difficult because you have to transfer the heat into the plastic. So that's where a hot end like this comes into play. It's got a really long melt zone. You can see the melt zone is longer than the CR Touch is there. And there's even a model that has an even longer melt zone. So right now I'm using this air-cooled model, which you can blow air through these fins to help cool it off. I'm not doing that right now. I'm just using it bolted to the stock hot end on this Sprite extruder. But yeah, this will allow you to just print crazy fast and transfer all the heat you need into the plastic. I'm sure Luke could give you a whole lecture on all the stuff required to get this stuff to melt. Yeah, there is an equation for that. So wattage required to get a certain amount of PETG to melt temperature. And then it's not just increasing the temperature of the plastic, you also have the enthalpy of formation, as they like to say in chemistry. But basically, like, you know, ice, you can heat ice up, and then at a certain point, it starts turning into liquid water. And it stops, like, your heat isn't heating up the ice anymore. Your heat is converting the ice into liquid. So there's like a certain amount of energy associated with that state of matter. And yeah, it's basically you'll have to add up. Melting this will happen in two chunks, or, you know, transferring heat will happen to it in two chunks. Basically, let's say you're constantly adding heat. I'm going to do a graph here. So let's say here's your y-axis. Here's your x-axis. Okay. So let's say you start out at a certain temperature, and you would think that the more heat you add to something, it'll just increase in temperature over time, right? Well, at a certain point, it'll start to melt, and then you're dumping heat into it, but the temperature isn't changing. So it flatlines like this for a while. And then once everything is melted, then it'll be a liquid that you can heat up. So, you know, you heat it up in one phase, it does a phase transition, and then you heat it up in the second phase. So whether you're boiling water or melting ice, that's kind of the way that works. So it's not all that complicated of an equation, but you have to know all the variables, and I don't want to do it. Okay, so yeah, this is 1.75 millimeter filament being fed in. It's being fed quite rapidly, as you can see. And yeah, it's just getting eaten up here. I'll just follow my finger. You see how fast that's going in. So right now we're going at 80 something cubic millimeters per second. This is with PETG. Just a clear PETG. Yeah, so Luke just mentioned something. So 1.75 millimeter filament is better than 2.85 millimeter filament for high-speed printing. And there's a couple factors at play there. So, oh yeah, let me see on my website if I uploaded the plate. Let me see. Oh yeah, I had it as a draft item, so I'm going to set it to active. And I don't want you to think that it's a good idea to buy this plate, but if you want to help me out and like participate in kind of beta testing this thing, it's going to be pretty fun. It's like something that I'm trying to develop to be the ultimate modding experience for Ender 3s. And it's going to have some crazy stuff. Like the next models, I can't do everything all at once, but the next models are going to have some extra craziness in them. So that's all I can say about that for now. So the hot end, yes, we've got a plutonium reactor in the hot end that's dumping 5 megawatts of energy into the plastic, and that's allowing us to maintain these flow rates. Yep. That's what's happening here. Don't question it. Yep, this is the tube hot end. Yes, it's the Demon Core. Yeah, so Luke is saying that it's not the surface area to volume ratio for your heating element, then you got to force it through a nozzle. Yeah, so For 2.85 millimeter filament, let's just call it 3 millimeter filament, it's about twice as thick as this standard filament. And the main application for that, I think, is for flexible materials. So, you know, the thinner you make your plastic, the more flexible it is. And if you're starting with a really flexible plastic to begin with, then it'll just be too hard to extrude and force into the hot end. So that's the main reason you'd want to go with a thicker filament. The other thing is you have to transfer the heat into this filament and melt it all the way through down to the core. So you have to travel, the heat has to travel a further distance to get all the way into the filament if you're starting with a thicker piece of filament. So a thin piece of filament is ideal because you only have to have the heat travel about 1 millimeter to get to the center. With 3 millimeter thick filament, you have to travel like 1.5 millimeters to get to the center. And basically, having heat travel over a distance is what's difficult. If you have something that's really thin, even like a piece of plastic, even like this plastic bag, which is made out of a material that is a very poor thermal insulator, since it's so thin, if I touch this, the heat transfers through it pretty quickly because of how thin it is. So whenever you think about heat transfer, you have to think about the conductivity of the material, the amount of surface area you have to conduct the material through, and the thickness that you have to conduct it through. So thicker things take longer to conduct heat through. It's as simple as that. You know, I got a pretty good grade in heat transfer when I was in college. So I just have a pretty good understanding of that, of how to transfer heat. And it's really interesting, but it's hard to find people to talk to about it. Okay, so I just know that my fat A sweats so much because my thermal mass increases faster than my surface area. Yes, also, your fat A also is thicker, and to transfer the heat from the inside of that thickness to the outside of it is more difficult. Now there's this really interesting stuff about heat transfer. There's two kind of competing forces at play. Basically, as you make something, like let's say you have, I wanted to insulate a burrito or a pipe, or let's just say, let me get something that I'd want to insulate in theory. So let's say I have this tool and it's heated up and I want to insulate it and keep it warm for a long time. Well, I can wrap it in insulation, and the more insulation I wrap around it, the better insulated it is, right? But mass and heat transfer is your least, yeah, least favorite. I really liked it. I hated thermodynamics though, which you would think they're related, but trust me, they're not. Heat transfer is a lot more fun than thermodynamics. So anyways, if you add insulation to this thing, it's gonna be more insulated, right? But counterintuitively, once you get past a certain amount of insulation, let's say you wrapped this in like insulation until it was like 1 meter thick. Well, eventually you get to a point where it's actually, the more insulation you add, the less insulated it is. Because as you add more insulation, you increase the surface area of the object. So more surface area means you lose heat faster. And those competing forces end up such that more insulation is less insulated somehow. If you want to learn more about that, just Google critical insulation radius, I think. Critical insulation thickness. Yeah, critical insulation thickness is the thickness after which heat flow decreases. I don't know. I need a whiteboard to really get into a topic like this, but we'll just leave it be for now. Okay, so now that we're up at 310 degrees Celsius, I think I can turn the speed up a little bit, so let's bump it up. So remember, my base speed for this test is 25 cubic millimeters per second. That was set in the slicer. If you look over here, when I go to the preview mode and we look at it by volumetric flow rate, it's all 25. The whole thing is 25 cubic millimeters per second because I set the limit in the filament advanced tab. And yeah, I just set it to 25 cubic millimeters per second. And this thing is laying down such thick layers that it's just maxing out that flow rate at all times. It's never acceleration or speed limited because look how fast it's moving. So 70 watt heater, Tube Air, $260. Yep. I mean, engineering and high performance components isn't cheap. So this hot end is more expensive than the printer. Well, actually it's not. These Ender 3S1s are a little bit pricey. But overall, you know, this is kind of a spendy rig that I have here. But, you know, you gotta have fun here somehow. Yeah, so I'm printing in vase mode, so there's no retractions. Technically, since I'm printing the first 2 layers of the print, it will do a couple of retractions since it's not technically in vase mode yet. Oh, the Benchy is part of my CR Touch holder. So the Benchy's holding on to the CR Touch there. I'm liking how Prusa Slicer lets you associate printer, print, and filament settings. Yeah, that's right. What filament is that? This is just a PETG clear. This one is Yousu filament. Yousu. Basically every clear PETG is the same. There's big money in marketing filaments, but I hate to break it to you, but if you get like standard stuff like this and you don't care about the specific color that it is, it's pretty much all the same. Now, someone's probably going to correct me for being completely wrong on this, but that's just my hot take of the day. I'm sure there's higher quality filaments out there, but for me, I just get the cheap clear stuff with no pigments added, and that tends to work pretty well for me. Okay, let me... I know someone was asking about this earlier, so I think the product is listed on my store page now. Yeah. So I put this plate on there. I've got a couple more of these. Some of them were from different manufacturers. Some of them are different alloys. So I've been experimenting with, sourcing these plates. But yeah, this is my modding plate that I'm going to base all my Ender 3 mods off of. No hot end, no sock. So I don't have a cooling fan on here. And that isn't for any good reason. That's just because I'm too lazy to put it on right now and I just got this running. Oh yeah, someone's talking about the K1. Yes. Hello from Las Vegas. Welcome. Yeah, Vegas is cool. They got some cool expos down there. I guess you guys just had CES in town. No, the Benchy's melted because I burned it with the torch to get it to be more sticky so that I could attach things to it. You know what? Benchy's never made sense. Since when have Benchy's made sense? Explain that to me. So the fact that it's, not making sense right now is no different than any other time. Okay, so we're at 350%. Someone do the math here. 350 times 25 cubic millimeters per second. I don't know what that works out to. I just turned it up a little bit, so 375%. Let's go up to 400%. So this should be requesting from this hot end 100 millimeters per second, 100 cubic millimeters per second. Yeah. So look how fast that's going. Look at this. And the extruder is not really struggling at all here. This thing's just blasting through this filament. It's kind of got an interesting texture right now, too. So this nozzle is from Slice Engineering. It's the 2.4 millimeter. Yeah, 2.4 millimeter diameter nozzle. So basically the outlet of the nozzle is larger than the inlet. I don't know how that works, but it does apparently. So yeah, the tube goes up to 500C. I haven't tested it to 500C, but I have a PT1000 heating sensor in there, so I should, in theory, be able to go up to temperatures that high. I just don't have any filaments that are, worth going that hot for. Right now I'm running this PETG way over temperature. So yeah, should get more interesting. Okay, all right, I'm gonna slow this down a little bit. It starts getting a little sketchy around 100 cubic millimeters per second. And I don't know what the issue is, but it's like kind of running over bumps. If I turned up the heat, then it could work. Maybe a little bit better, but yeah. How much watt heater? It's only a 70 watt heater. There's the part cooling fan is not existent. There's no part cooling fan. Here's the hot end fan. I think the Sprite is okay, maybe. I think what's happening is this nozzle is allowing the unmelted. I actually don't know what's going on here. I think with the right setup, you can definitely get this going over 100 cubic millimeters per second. But it's just this hot end isn't really, it's not really on there very well. What the heck? This is way wobblier than I thought it was. Okay, yeah, that's probably the problem. It looks like it's starting to like bump around. It's like, and that probably has to do with the way that I have this mounted. Yeah, I need to tighten up those V-groove wheels. Okay, hold on. Let's get that done. Okay, so the issue is I get a little nervous. I can't fit the wrench in here, so because it's too low down here, but we have a fix for that. Ta-da! There's our special wrench. A low profile wrench, so we should be able to get it in here. And tighten up this V-groove wheel. There we go. Low profile wrench mod. So, all right, now let's try turning up the speeds, because basically the extrusion forces were causing this thing to like rock around back and forth, and I was getting a little nervous. So let's just turn up the speed again, see if we have that same issue. All right, now we're going 100 cubic millimeters per second. 310 degrees Celsius using PETG. Kind of generic PETG. This is from Yusu. I've never, yeah, eventually you'll get to a point where the Sprite, it'll just stop spinning. And I don't want to get to that point, because then the extrusion completely stops and it makes a gap in the print. So I don't want to go too crazy with pushing it on this model. Like, I do want to have a successful print out of this, and I'll do some test prints later that'll be a little less, critical if it fails. So I won't mind if you know, it breaks down and ruins a small print. But right now I'm working on something big that I want to have. Okay, so Luke's Lab is here. He's telling you all about the Tube hot end. This is his product on his website. Very high flow hot end. Now, should I go over 100 cubic millimeters per second? I just set it to 125. This might be a terrible idea, and it might ruin everything. But, oh no! Oh no! All right, well, there's the limit. I'm pretty sure the hot end heater got overwhelmed, and it shut down. So, there's that. So 70 watt heater, I need to step it up a little bit. Maybe go to like a 100 watt heater. Oh man, error code. I don't know. I didn't have my console up. Oh, resume? This could be the worst idea ever, but I'm just going to tell it to resume and see what happens. Okay, so will it actually resume printing out of this? It seems absolutely crazy. Right now the temperatures aren't set to the right thing, so I think it has to cool off to a certain temperature where it'll be like, now I can do my startup procedure. So yeah, well, the temperatures are set in this model to be just like what it says here. $270C for the nozzle and $80C for the bed. So maybe this is yeah. Oh yeah, good point. Mark Frank, thank you for your quick thinking. I will do that. So let's set this to 310, then set the bed to 80. And yeah, when that gets back up to temperature, hopefully it'll resume printing. We'll see what happens. Also, I guess I'll just leave the speed at 100% for the first little bit, and then I'll crank it up again. But yeah, I mean, I didn't realize that 80 watts or 70 watts wasn't going to be enough. But, you know, I don't really print at these super high flow rates all that often. So maybe I need to up that to like 100 watts. That'd probably do the trick. Okay, so it's waiting to hit, you know, oof, it's got to cool off. So now it's at 200C and it's like, okay, that's good. All right, let me log into Klipper. I need to switch. I was on my phone's hotspot. I need to get back on the network here and see what the error code is showing. Okay, so let me just see what's going to happen here. Ooh, okay, okay. Whoa, what the heck is going on? What is going on? This is not good. Oh, okay. What the heck was that? Did you hear that? That was bizarre. Now it's printing though. It's a success. Okay. Anyways, let me turn the speed back up. It's getting overheated. We're doing it live. Okay. All right, so I actually wasn't connected to the Sonic Pad the whole time, so I probably missed out some of the error codes and stuff. Console. Yeah, it's probably missing some things here. Anyways, so right now, since I have the filament set to such a high temperature, it's actually bubbling. It's foaming as it's coming out of the hot end. So I need to turn up the speed to compensate and bring that temperature down. I could also just turn the temperature down, which would be the logical way to solve this problem. Oh man, downloading log files? This doesn't sound fun at all. Wait, hold on. Can't I see the PID percentage? Yeah, see, it was at 100% and the hot end temperature was going down. Here. It was at 100% throttle this whole time, and it was like 20 degrees away from the set point. And then when I sped it up even more, it slowed down too much, and the heater cartridge got overwhelmed. Okay, so I guess the max speed that I can go with the current heater cartridge is probably, we'll just leave it at 350, which is 3.5 times 25. Does it show volumetric flow rate? Yeah, flow rate 88.4 here. That's not right. It's fluctuating a lot, but it should be like 88.4. AC hot end heater? Yeah, that sounds fun. All right, one sec. I gotta check my text messages, so if they show up on my screen, don't read it, okay? Oh man, you got my text? Damn. Okay, so let's see how this is working out. It's feeding at the right speed. What do you think of this texture? Should I go for smoothness? I just need to turn the temperature down to get more smoothness here. Temperature. I don't need to have it as hot as it is right now. Maybe 270. That'll probably produce a much better surface finish, and I might need to turn the speed down. We'll see how it goes. The nice thing about having this much filament flowing through here is it's actually going to cool off the hot end for me. So we're carrying away the heat in the plastic. So I'm going to increase the flow here and decrease the speed. Uh-oh. I got the stepper motor skipping there by requesting too much from it, I guess. I'm definitely running up against the limits of how fast I can go on this the extruder that I have here and the heater cartridge. I think there's more overhead for this hot end, particularly with like, you know, different materials or a different nozzle. But yeah, it's looking pretty good. So what I've done now is I increased the flow to 125%, and that's going to produce a fatter extrusion. It's just going to basically feed more through the extruder for the same motion, and it'll just make the plastic squish out to the sides more. Propane powered hot end would be pretty nice. I've thought about gas powered, and in reality I just don't think it's all that practical. So this filament does this kind of beaded appearance when I'm printing at these speeds. I don't know, what do you guys think of it? Do you like it? Should I go for like super glassy smooth? I kind of like the smooth stuff, so I think I need to slow down a little bit to get that. The thing is that I'm dealing with viscous forces past a certain point. Like, I don't know if I'm getting into a turbulent flow regime after turning it up so fast, but you can see slowing this down makes the extrusion look a lot better. Because you're just giving more time for that plastic to flow. Alright, I'm going to try and get it smooth then. One person agreed that I should get it to smooth out, so I'm going with it. So I think to do that, I probably need to turn the temperature down a little bit. And turn the speed down a little bit. That'll probably get me my smoothest results. Yeah, that's looking a lot better already. You probably can't tell on the camera, but I can see it with my own eyes. Clearly needs very slow. Yeah, I think, yeah. There's a lot of tuning that has to go into something like that to get like optimal print speed and surface finish for whatever your objectives are. Maybe I could heat it up a little bit. I think actually heating it up will make it smoother. So I'm gonna bring the temperature back up to 275. Because you want it hot enough that it's like super liquidified, but you don't want it too hot where it's bubbling and the water inside of it is boiling out. But it's looking pretty good now. I'll give it a couple layers so that you can see what effect these new parameters have. You can it's just so fun to watch this filament being fed in. This is a bit slower than I was running earlier, but for a desired surface finish, I don't mind changing the speed. And I think I need to dry this filament as well. This is just some stuff that's been sitting out for a long time, so it might not have the best moisture content. I'm gonna try and get some good shots here. Printing like glass method. All right, let's do one pass with this slower speed and see what it looks like. Yeah, I've got a video on this. The problem is it's like 10 hours of footage, this printer. I've got a lot of crazy things going into this project, and it's something that's going to be something that I'm going to be working on for the next several months. Yeah, so Mark, the printing like glass method, I don't think that applies to vase mode. I think vase mode inherently prints like glass. But he might have some tips on doing the temperature tuning and all that kind of stuff that could be handy. Oh yeah, the modded Ender 3. I think it's sub 2 minutes at this point. This is by Monica. Um, you can check that out on YouTube, and I think there's a Tom's Hardware article about it as well. Alright, so, this is just going to be running for a while. You guys want to talk about any current events? If you don't follow me on Twitter, you should. I'm shit posting on a weekly basis there. I try not to spend too much time on it, because I think my time's much better spent working on stuff like this. It's much more enjoyable, and I think it makes for better content. But for some low effort trolling, Twitter's always a good place to go. Spill the tea on Bambu? There's no tea on Bambu. Bambu's a wonderful company. The one thing how do you end up fixing VFAs on the K1? Slowing down the print makes VFA worse for me? That's interesting. I only tested it on the K1C, so maybe it's those smaller pulley gears that are making the difference. And it could be another cause of the issue altogether. This is cool. Flow rate right now is hold on, let me turn this down a little bit. So flow rate right now is 125% flow rate and 160% speed. So multiply those two. So 1.6 times 1.25 times 25. I can do the math here. 1.25 times 1.6 times 25. So right now we're running 50 cubic millimeters per second. 50 cubic millimeters per second. But this is in the pursuit of getting better surface finish. Like, I want to try and get this as smooth as possible. We can easily turn this up to, 75 or 100 cubic millimeters per second. But at that point, I need a larger heater cartridge. Oh, 110? Okay, thank you. Luke's Lab will send me a beefier heater cartridge to test out with this thing. Then we'll push past 100 cubic millimeters per second on this PETG. I think I could still easily go over 100 using the using some PLA. Oh yeah, about Bambu Lab and their new thing. I think they're downplaying the issue. I think that there's something more serious going on that they either don't fully understand or they don't want to admit. So, we'll see how it goes. In any case, they're being pulled off the shelves at Micro Center stores, and they're not selling them on their website at this point in time. I don't think a little clip-on strain relief is going to fix the problem. Aren't you glad I wasn't one of the big-time Bambu Lab A1 shills? I mean, everybody's got egg on their face at this point. And everyone's like, oh yeah, Bambu Lab #1, best quality, everything. Oh yeah, no, all the other companies suck. And it's like, guys, chill out. There's a lot of good 3D printers out there. Like, you think I could ever do something like this on a Bambu Lab printer? There's no way. So I am always going to be in favor of having this type of printer where you can do whatever the heck you want with it and just have fun. Yeah, so that's with slowing down a little bit. I'm sure there's a way to improve it even further. Like, this PETG is almost certainly waterlogged. Like, I need to put it in a dehydrator or something to get these last bubbles out. But yeah, the layers are looking a lot clearer now, and there's none of that ripply pattern. How big the layers? So that's a somewhat interesting question to answer. So if we look at our layer width, I have it set to 5 millimeters layer width and 2 millimeters layer height. So 2 by 5, and I actually set the flow rate to 125%, which will make the layers wider because, basically I'm over extruding by 25%. So instead of being, what it says here, 5 millimeters wide, it'll be 5 times 1.25, or roughly 7.25 millimeters thick. So 7 millimeters thick. This is almost a full centimeter. So this will be a very strong structural print when I'm done with it. Yeah, I just really like printing stuff like this because it shows what's possible with 3D printing. I think most of the stuff that gets 3D printed is considered weak because the layers are thin and you've only got 1 or 2 layers that are 0.4 millimeters thick. You're looking at less than a millimeter of layer height. But this here was printed with roughly the same settings, with the same filament. And this is super strong. You could drive over this and it would be fine. I could just go get my car real quick and run this over. But I don't know. I don't think there's a point in doing that. I can hit it with a hammer, or I can put it in my vise over there and squeeze it until it pops. Let me know if you're interested in seeing any of that happen, or something. Oh, inductive heater on all metal hot end? I don't know. What's the point of an inductive heater again? Can you explain that to me without without sounding like a sales pitch? Will it blend? I don't want to ruin my blender on this thing. The inductive hot end, I mean, it's pretty interesting, but it's not really useful for most applications. It's not like, for us hobbyists, it doesn't make sense to get something like that. Ooh, look at these layers. That's cool. I definitely need to get some new PETG, some clear stuff, and do this over again, because I feel like I'm not doing it justice with the way that this is set up. But if I really cranked up the flow rate and got some, maybe even a hotter heater, or Luke, maybe I could get the remainder of that turned into a hot end instead of part cooling. I suppose if you design it right, you don't have to worry about molten metal ever touching your hot end. Oh, you know what was cool? I think the coolest thing to happen in 3D printing lately came out of MIT. They are doing molten aluminum printing into a bed of sand. That's really interesting to me. It's like casting without a mold. Aluminum casting without a mold. Need 48 volt extruder for more spinning, bigger heater, and conduction. Okay, all right, so I've got this. So I've got the 48 volt stepper drivers here. Bigger heater. Yes, you said you have one of those. And conduction. So what Luke means by conduction is this hot end is the air-cooled tube hot end. And you can see this whole section is the melt zone. And then up here you've got a heat sink that allows you to, I think it's like reverse compatible with the V6 style hot end. So it's got the same diameter and you can blow air through it and you get it going. And then, oh, that's a good point. Luke just brought something else up that I'll address in a second here. But there's the tube hot end, which is air-cooled, and this one is air-cooled. So there's some heat sink fins up here. But on the conduction version, this area up at the top, a lot of that is replaced with just more melt zone. So it's the same overall length, but you've got more melt zone in there, which means more faster melting plastic. So I could speed things up even more. But the other thing Luke just mentioned is he asked, what's the size of the Ender 3's, what do you call it? The power supply. Because I might be getting to a point where I would be running out of power to deliver to the hot end. Normally, the heated bed is the largest consumer of power on your 3D printer. This is about 200 to 250 watts. But if I'm adding 130 watts of heating to the hot end, then we're talking about a situation where you might, or too much power. So yeah, this is looking pretty good. It's not going to be perfectly clear, but it'll have its own type of charm to it. Woo. I'm going to get a light and start playing with that. Let me get my LED light, 1 second. I don't know how to make this look cool. Okay, fair enough. But I'm thinking LED lights and stuff. We need some RGB LEDs up in here. Slap, do what John said. What did John say? Oh, water cooling? Yeah, I mean, I could do water cooling. It would actually make sense on this application, I think, because this is moving so slow that you don't have to worry about all the extra cycles. That's one thing that really bugs me about the way 3D printers are designed and marketed right now, is everything's all about speed and acceleration. And the downside of speed and acceleration is increased wear. Like, if I printed this same object on, let's say, a Bambu Lab X1C, instead of going around to produce the same wall thickness and the same everything, the same amount of material, I would have to do, well, I mean, we can calculate an exact number, but I'm going to ballpark it and say one extrusion width is 7 millimeters on this, so that would require like 20 passes on a 0.4 millimeter nozzle. And then when you look at the height, you have to do, let's say you're printing at 0.2 millimeter layer height. On this, I'm printing 2 millimeter layer height. So, 20 times more passes to produce one layer on this, and 10 times more passes on the top to produce one layer like this. So you're literally doing 200 times more cycles to produce the same part. So the amount of wear that this machine experiences is 1/200th, just because you're producing the part in less motion. So I think this is the kind of thing that we need to be focusing on if you want to make reliable machines that last a long time, that can replace traditional manufacturing. Luke's saying large nozzles are amazing. 1 millimeter nozzle parts still look good if you can stack your layers. Yeah, that's true. I've done a lot of that. I think, I just think it's kind of an underserved niche. We need to have more fat layer stuff. So yeah, this is going to have a couple little bubbles in it because of how wet this filament was apparently when I got started. But let me turn this off. You've got 0.8 and larger. The problem is that printing this kind of stuff is expensive. You go through a lot more filament. But if you're okay with that, then I'm okay with it. Okay, guys. Well, I'm gonna log off at the hour-and-a-half mark, so in 4 minutes. But if anyone has any last-minute questions, let me know. The hot end here is from Luke's lab. You can go to his website, Luke's Laboratory. Just Google it. He sells 3D printer stuff and builds 3D printers here in the state of Wisconsin. And he's, developed this with a couple of colleagues. It's the tube hot end, very high flow rate. John Stern asks what the max flow is. Luke should tell you. He knows better than me. I don't have this set up on an optimal system. I literally just slapped this on an Ender 3. So you're not going to get peak performance out of it. But it sure is fun. And it's definitely extruding a lot of plastic. I went up to 100 millimeters cubed per second earlier. But then I ran into issues with... basically, the nozzle was cooling off too fast because the heater that I put in here is only 70 watts. So I need a bigger heater, need faster stepper motor drivers, and all sorts of stuff to really crank the speeds. But we've had quite a bit of fun with it so far. What is this ancient technology? King Sidorak, the bamboo shill, has showed up just in time to piss everyone off before we leave. Just kidding. King Sidorak's on our Discord. If you want to join, it's kind of a fun place. I post some pictures of my projects that I work on, and we all like to help each other out and just share fun stuff that's going on in the current events in the 3D printing news space. So check that out. I'm not sure if it's in the description. I don't know if I made a description for this video. How long did it take to install? This one, I've been documenting it, so I'll have a video on it. Altogether, this whole build has taken me about 3 days so far because I've been doing all sorts of crazy stuff, including this aluminum base plate that I've been developing. Only have a Slice Magnum. Well, Slice Magnum is pretty fast too. I think this is a little bit faster, but you'll get plenty good speeds out of that, right? I just cleaned up some filament just because I'm curious what that would happen. Yeah, I mean, I don't know what you would call this equivalent to. I think the conduction hot end is probably similar to the Mosquito Magnum Prime. So Magnum Prime is, the price is almost a meme, $1,000. So this being a mere $200 to $300 is quite reasonable. But the nice thing about this thing is it looks like it's not ever gonna break. Like, I'm not dumb enough to hit this thing with a hammer, but I am dumb enough to accidentally run it into a bunch of stuff when I was configuring this printer, and it definitely survived. So it works. So yeah, any last questions about what we got here? Low bar there, it's better than the A1. Yes, this is safer than the A1. This is safer. Stronger than Goliath? Yeah, I mean, the main thing with this extruder is this external, the hot end, is this external frame that's carrying all the load. So that's what's going to be providing a ton of strength. Tubes are very strong, so that's the basis of the tube's structural design. Just noticed the Benchy? Oh yeah, there. That's my my CR Touch holder. The frame looks nice. Which frame? Oh, this bottom thing? Yeah, this is like a... I've made a bunch of these. I've got them on sale on my website. If you look up nathansellsrobots.com. I'm selling these, but it should be understood that it's like a beta test thing. This isn't like a full product yet. I don't have any of your mods. I mean, I can make my own mods. Look, I got my Benchy mod, my ridiculous industrial hot end mod that's capable of over 100 millimeters cubed per second. My Modderboard mod helps me break out these connections from the 24-pin connector into the standard types. And then I got my bundle of wire mod. Well, I gotta go. Thanks for joining the live stream today. And I'd like to... King Sid's unsubbing. I'm sorry.